discuss the core model that we'll be using to explain the various tools in econometric analysis. So basically, this video is about the basic or the starting model that will form the core of the advanced econometrics techniques that we will learn through these videos. So whenever we talk about cause and effect, as we discussed in the last video, so in case of cause and effect, the outcome of interest, the outcome of interest is referred to as the dependent variable, while the possible cause is referred to as the independent variable. So formally, an independent variable which is usually denoted by x is a variable that possibly influences the value of the dependent variable. Now, why is it called independent? Because as the name says, so it can take any value. So it does not have to depend on the values of the other variables, so it can take any value. But the dependent variable denoted as y is the outcome of interest and its value depends on the independent variable. So why is it called dependent? Because it cannot take an independent value. Its value is dependent on the independent variable. So that's why it's called as the dependent variable. So to summarize, in any cause and effect problem, so the cause is the independent variable denoted as x, while the effect is the dependent variable denoted as y. So basically, any cause and effect relationship supposes that a change in one thing, which is the independent variable, will lead to a change in another, which is the dependent variable. So that's the statement in the cause and effect kind of problems. Okay, so we'll formalize this relationship as we move forward. But before doing that, let's first start an example. suppose we are interested in studying the reasons behind the US obesity epidemic, and let's say, so we are interested in studying what are the factors that have led to a recent obesity epidemic in the US, and one of the factors that we think is to that the increased consumption of snack food. Okay, so basically we want to analyze, let's say, of all the factors that could lead that have led to an obesity epidemic in the US. We want to analyze, let's say, we want to analyze the influence of snack food like donuts, burgers on obesity or health. Okay, so when we say snack food, so I'll have to uh, define what a snack food is, or I'll have to take an example of a snack food. So let's say I want to see. So my question is, does consuming more donuts lead to higher weight? So it's a simple question that does consuming donuts increases a person's weight? I want to analyze this. Okay, so in this model, the independent variable, that is X, is donuts, and the dependent variable, Y, is weight. Okay. So now we need to collect data to analyze this relationship. Okay. Now, so when I say I need to collect data, so obviously we cannot do it for the entire US population because that's not practically possible. It's not feasible. It would be costly. It would be time consuming. So in this case, we'll take a sample of people. We'll take a sample of people, and let's say we take a sample of 13 individuals from a sample of 13 individuals from a randomly chosen town. Okay. So let us refer to that sample. So this is the raw data. This is the raw data of 13 individuals from a randomly chosen town. And so the first column is about the observation number. So there are 13 people. Then you have name, and then donuts per week, which is our independent variable. So so in the sample, so basically we asked how many donuts do these people consume per week, and then we note down their weight in pounds. So this is our dependent variable. Okay. Now you have to understand that if we plot a scatter plot of this data. Now, what is a scatter plot? So, in the case of a scatter plot, so you basically have two quantitative variables on x-axis and y-axis. So here it's donut consumption on the x-axis, the number of donuts per week that the person is consuming, and his or her weight pound in pounds on the y-axis. So if we talk about this person, Lisa, so this is her. So the value on the x-axis, which is she's not consuming any donuts, so that's 0, and her weight is this. So this is her weight, and this is the amount of donuts that she. If we talk about this person part, so he is consuming 5 donuts per week, and his weight is this. So a scatter plot basically plots a combination of x and y values. Okay, so this scatter plot roughly suggests that if, if roughly it says that there seems to be a positive relationship between donut consumption and the weight of a person. So again, so this basically points to the fact that there is correlation between people consuming more donuts and people having higher weights. Whether that's causation, it is something that we cannot answer at this stage. Okay. So let's come back to the question. So the question is, does consuming more donuts lead to higher weight? So the answer is not straightforward. To basically analyze this, we have collected data on 13 individuals, and we of all these individuals, we have asked them about the number of donuts they consume per week and what is their weight in pounds. Okay. Now you have to. The second thing that you have to understand is that in talking about a sample, we'll often talk about xi or yi. Now, what are these xi or yi? Xi or yi refer to the values of x and y. Xi or yi refer to the values of x and y, that is the independent variable and the dependent variable, for person I in the data set. Okay, so let's say if I write weight 7 is equals to 160, so this basically means that the weight of the seventh person in the data set is 160 pounds, and the seventh person is Mr. Smithers. Okay, now we will use a simple equation, to characterize the relationship between the two variables in this case. So this equation is weight I is equals to beta naught plus beta 1 donuts I plus epsilon. Now let us understand the meaning of all these terms. So the dependent variable, so weight I is the dependent variable, weight I is the weight of person I. The independent variable donuts I is how many donuts person I eats per week. Okay, so this is clear. Now let us talk about what do we mean by beta naught, beta 1 and epsilon. So beta 1 is actually the slope coefficient on donuts, which basically indicates how much more a person weighs for each donut eaten. Okay, so this basically tells us, this coefficient beta 1, that if the person's consumption of donuts increase by one more unit, then how much more the person's weight increases. Now to understand this, so basically beta 1 you will get by differentiating this equation. So our equation weight is equals to beta naught plus beta 1 donuts plus epsilon. Okay, now so if I differentiate this weight by donuts, so since this we'll discuss is a constant, so it is 0, this will be beta 1, and this would be delta epsilon by delta weight, so delta epsilon by delta donuts. Now, which we will see later that we take this to be, and this is a very key issue in econometrics, we take this to be equal to 0. This will come to later, but for now, so beta 1 basically means in a discrete sense, it is change in weight by change in donuts. So if change in donuts is 1, then beta 1 is the change in weight. So if the consumption of donuts increases by 1 unit, then beta 1 basically gives you the change in weight. Okay, so in general, you can write that beta 1 or the slope coefficient, it is the coefficient on an independent variable. It reflects how much the dependent variable increases when the independent variable increases by 1 or 1 unit. 1 basically is 1. Okay. Now, beta naught is the constant or intercept. It is the constant or intercept which basically indicates, in this case, it indicates the expected weight of people who eat 0 donuts. Now, why we are saying, so we have introduced a new term here, that is expected. Okay, so expectation in statistics has a particular meaning. It basically refers to the average value of a random variable. Now, in this example, so the equation again is weight is equals to beta naught plus beta 1 donuts plus an error term, which we will explain. Now, if we take expectation on both sides, so expected value of weight, so since this is a constant, so it would be beta naught only plus beta 1 E of donuts plus E of epsilon. Now we are talking about the case where donuts are equal to 0, and as we will see later on, we take the expected value of the error term to also be equal to 0 because we assume this to be random. Again, we'll study this in detail. For now, you just remember that. So two things we discussed regarding the error term. One is that the error term, so basically there is no impact of a change in donuts on the error term, and there is no impact, and the average value of the error term is assumed to be 0. Okay, so these two assumptions we have taken here. So in this case, when donuts is equals to 0, so beta naught will give you expected weight. So the intercept is the average weight of people who do not consume any donut. Okay. Now, let us formally define the error term also. So epsilon I or epsilon, when I say I, so it's for a particular observation. It is the error term that captures anything else or everything else that affects weight. So there could be a host of other factors that affect a person's weight, irrespective of his or her donut consumption. So these factors could be, the person's age, the person's genetics, the person's physical activity. So it's not just donut consumption that affects weight, it could be several other factors that affect weight, and those are included in the error term, which is epsilon. Okay. Now, Using this equation, we will actually draw what we call as a regression line. We will plot a regression line using the original equation. Okay, so again, how do we do that? There's a procedure called as ordinary least squares. We will learn that in the subsequent videos. Okay, but for now you have to remember that using the original equation, that was our core model, which we can generally, so using our core model, so which is generally represented as, so now we are not writing donut and egg, we are giving general notations to the dependent and independent variable. So yi is equals to beta naught plus beta 1 xi plus epsilon. So using this equation, we will plot a regression line for our data. Now, you have to understand that this is not the regression line. This is the original model. This is not the regression line. This is the original model. We actually plot a regression line using this model. Okay. So to give you an example, so in the weight and donuts case, in the weights and donut case, the regression line will look something like this. Okay, so the regression line looks something like this. So which has been plotted based on the observations of 13 individuals. Okay, so the intercept of this regression line. So since it's a line, it has a form which is of the type y is equals to mx plus c. This we have learned in our schools, that equation of a straight line is of the form y is equals to mx plus c, where m is the slope and c is the intercept. So the slope here is beta naught, which is 123, and the intercept here is beta naught, which is 123, and the slope is actually around 9.1. Okay, so the slope basically means that for each donut eaten per week, the weight is about 9 pounds higher. Okay, now the important thing to note here is that the actual observations will not fall on this line. So like the observation for Lisa, the observation for Bart, the observation for Selma, the observation for Homer are not on these lines, are not on this line. That is something which is very key to understand here is, now they would have been on this line if their weight could just be explained by the amount of donuts that they would have been consuming. Okay, so it could be that, so in cases where if you could just plug in the value of a person's consumption of donuts and you could get his or her weight, then all these points would have fallen on this straight line. But the thing is that there are factors other than a person's consumption of donuts that also influence his or her weight. So those, because of those factors, these will not necessarily lie on on this regression line. The regression line basically explains weight only due to consumption of donuts. Okay, so to formally write this, the actual observations do not fall on the regression line that we are trying to characterize, that we are trying to use to characterize the relationship between donuts and weight. The implication is that our core model that our core model does not perfectly explain the data. This is because there are several other factors. This is because there are several factors other than weight, other than donut consumption, that influence or affect a person's weight. For example, factors like person's gender, height, other eating habits, exercise patterns, genetics, and so on. So basically, the error term includes everything that we haven't measured in our model. Okay. Now the last thing that we'll discuss in this video is that we often refer, as I just discussed, epsilon I as random error, as random error. Now, you have to understand here is that it is not random in the sense of a roll of the dice. Like So when we say random, random basically means that if I throw a dice, that any number can come. But for this, we are calling it random because we don't basically know what the value of it is for any individual observation. Okay, for example, so genetics is not random because it came from that person's mother and father. But since we do not know that person's genetics, so for us, we are treating it as a random. So it is random more in the sense that we don't know the value of it for any individual. We don't know the value of it for any individual observation. But as a practical matter, every error term reflects at least partly some relationship to real things that we have not measured or included in the model. So what does this basically means that we are calling the error term random in the sense that it basically accounts for the factors that we could not measure or have not included, but those were not random in the sense that they were not like they were determined by some lottery. Okay, they had some real relationship with the individual, but we have not included or not observed that relationship. Okay. So in the subsequent videos, we will discuss what is the main issue with this simple model, and then we'll turn to how do we actually determine the regression.